Hi, in this video I'm going to show you how to write the net ionic equation for acid-base equilibrium reaction. Now in the first problem it said equal volumes of 0.25 molar acetic acid, which is 0.25 molar of HC2H3O2, and we also have 0.25 molar of KOH, potassium hydroxide. Now it's combined by the net ionic equation. So to do that, I'm gonna do first. Let's separate each of these into its salts, into its cations, right? H plus plus C2H3O2. This itself is a weak acid, so this is a strong conjugate base. So we're gonna keep this. Now KOH, K, let's write into K plus plus OH minus. Now KOH is a strong base. That means K plus is a weak conjugate acid. Now since K plus is a weak conjugate acid, we're not going to include it. It is not going to be included in this reaction because it will have no affinity for water. No, it will be included, but it's just going to sit there as spectator ion. So now let's write K plus plus OH minus plus H plus plus C2H3O2 minus forms, let's see, K plus will be over here as well, since it's what do you call it, spectator ion, and then these two will form H2O together, and finally leaving us with our C2H3O2 minus. Now the net ionic equation, we're going to cross out anything that's not used, and it's going to be K plus. We're going to cross K plus out, which makes us OH minus plus H plus plus C2H3O2 minus will make us our H2O liquid plus C2H3O2 minus. Now for the next one, we need to find the ionic equation again, and this time we'll be dealing with 0.1 molar of NaC2H3O2 sodium acetate and 0.1 molar, oh shoot, 1.0 molar, sorry, obviously that 1.0 molar, so it's going to be 1.0 molar of NaC2H3O2, and it's going to be 1.0 molar of HCl, hydrochloric acid. Now great, this is going to be Na plus plus C2H3O2 minus. This is going to be H plus plus Cl minus. HCl is a strong acid, which means Cl minus is a weak conjugate base. Since it's weak, it's not going to be in our ionic equation. Same goes for Na, and I just explained the previous one. This is also going to be positive. But when we're writing the normal equation, we're going to include them. So normal is going to be Na plus plus C2H3O2 minus plus H plus plus Cl minus, and let's see, what will this form? This will just form HC2H3O2. Why? Because the Na is not included and the Cl is not included. So when you add these two together, it's just going to simply form this. And now so let's rewrite it as a net ionic equation. It will be C2H3O2 minus aqueous plus H plus aqueous forms HC2H3O2 aqueous. Now finally, exact volumes of 0.2 molar and 0.4 molar. One is sodium sulfate, which is Na sulfate 2SO3 sulfite, sorry, and the next one is hydroiodic acid. Now this one will break into H plus and I minus. Well, let's keep it over here for now. This one will be N2Na plus plus SO3 2 minus. Now, since there's 0.4 molar, in the previous one it's all equal molar. Now since this one has 0.4 molar, that means there's double the amount of moles of HI. So this is going to be 2 HI, it's going to be 2 HI, and it's going to be 2 H plus, and it's going to be 2 I minus, because everything is double. Now let's draw a giant beaker to show you what is going on in the solution. So first, let's put everything in. There's 2 Na pluses. Let's put times 2 of each. So 4 Na pluses, 2 SO3 2 minuses, 4 H pluses. All right, we're gonna put two. We're gonna put 2 molar of each. Two samples of each. 4 H pluses, 3, 4, and 4 I minuses. 1, 2, 3, 4. As explained earlier, I minus will have no affinity for water, so we're gonna cross it out because HI is a strong acid, so this is too weak. And now Na is also too weak, so this is also gonna be crossed out. Leaving the only thing that can form bonds together is H plus and SO3 minus. So for every 2 H plus, we're gonna bond with 1 H. For every 2 H plus, we're gonna bond with 1 SO3 2 minus. So there we go, and there we go. So now these are going to be forming bonds together. So what does this have? We have SO3 2 minus plus H plus 2H plus forms H2SO3 SO3, and this is our net ionic equations. As you can see, everything else is not used. They're just sitting there, so they're the spectral ions and they will not be used. Now the next step, we need to find identify the aqueous species that have the highest concentrations at equilibrium. Now in this case, we're gonna need to include everything, right? Not only the net ionic, we need to include the rest as well. So now let's write the normal equation, which will be everything: 2 Na plus SO3 2 minus plus 2H plus 2I minus, and this will form H2SO3 plus all of our other all of our other spectral ions. Now to start off, we have Na, we have 0.2 times 2 moles, or 0.2 molar times 2 moles, which is going to be 0.4 molar. So it's going to be 0.4. SO3 2 minus, we only have one of them, so it's going to be 0.2 molar. 0.2 molar. H plus, we have 2 molar, so it's going to be 0.4. And I minus is also going to be 0.4 because everything is already doubled. Now, which one's the limiting reactant? By the way, this is going to be RBCHR, right? Which is the limiting reactant? This is limiting reactant. So minus 1 over 1, 0.2, minus 2 over 1, 0.2, minus 2 over 1, 0.2, minus 2 over 1, 0.2, which means there will be 0 for everything. Now, this form, it will be 0 in the beginning, initial, plus 1 over 1, 0.2, plus 2 over 1, 0.2, plus 2 over 1, 0.2. So this will be 0.2 molar, 0.4 molar, and 0.4 molar. So which concentrations will have the highest which substances will have the highest concentrations at equilibrium? Well, this one has 0.4, this one has 0.4, and this one has 0.4. Our H2SO3 unfortunately only has 0.2. So the ones with the highest concentration will be Na plus and 2I. It's going to be Na plus and I minus. We don't need to really include the coefficient. So the two substances that have the highest concentration at equilibrium is going to be Na plus and I minus. And that's it for this video. Thank you for watching.